Hello everyone, JCE Connect. I welcome you all for this particular lecture. In this particular lecture, I'll be solving a few problems which are being asked in university question papers. So by taking those problems, I'll be solving problems on specific energy. So here the problem given as a discharge of water through a rectangular channel of width 8 meter is 15 meter cube per second. When the depth of flow of water is 1.2 meter, calculate the specific energy of the flowing water, critical depth and critical velocity, value of minimum specific energy. So this is the problem asked. So this problem is so simple problem, but usually the in university question papers this type of problem will be asked for 8 to 10 marks. You can easily get 8 to 10 marks by simply by remembering the conditions for critical depth or critical velocity and the minimum specific energy. You can easily get the 8 to 10 marks. So first thing is what you need to do, you have to write the given data first. So what are the data given, you have to search. So what data are being given and what is needs to be find here. First I'll write the given data, that is b equal to 8 meter, that is width of the channel. The channel section mentioned is a rectangular channel section. The discharge passing is 15 meter cube per second. Just write q is 15 meter per second and the depth of flow in this channel is given as 1.2 meter. Then what is to be find here? The energy to be find, that is the specific energy. Then critical depth needs to be find, and the corresponding critical depth, what is the critical velocity, then the minimum specific energy. So once you know the critical depth, the minimum specific energy can be easily calculated, because minimum specific energy formula we know in terms of critical depth. Then what is the equation needs to be used to calculate the specific energy? The specific energy equation, we know that at any section the specific energy equation can be written, that is depth of flow plus the kinetic head at any section. So if this is the channel section, if you take any section, wherever you take, the specific energy can be easily written, that is with respect to the channel bottom the specific energy can be measured, that is y plus v square by 2g. This formula we're knowing. So knowing this formula, so in this, what are the unknown here? The velocity is the unknown here, q equal to a into v. From this formula we can get the velocity, q by a. Then what is the section area? The section area is b into y. Then substitute here, you will get the velocity. Once you know the velocity, then substitute back in this equation, you will be getting the energy. So once you know the energy, then next you calculate critical depth. So the critical depth formula will be what? Cubic root of q square by g. So this small q represents the discharge per unit width of the channel. The discharge passing per unit width of the channel. Discharge by width. We know the discharge width also we know. Substitute here and get the discharge per unit width. Once we get small q, substitute back in critical depth equation, you will be getting the critical depth in a channel, 0.71. So the problem is simple. Your only thing is you remember the equations. Okay. Next is critical velocity. So critical velocity, so we know the formula again. The critical velocity is root of g into yc. G into yc. So where yc is the critical depth, vc is the critical velocity. Substitute the value of yc here, you will be getting the critical velocity. Then the minimum specific energy can be expressed in terms of critical depth. So 3 by 2 into yc, this formula we are having. So just use this formula and substitute the value of yc here, you will be getting the minimum specific energy in the channel. So these problems are so simple. Generally they will be asked for 8 to 10 marks in an exam. But sometimes in competitive exams also, like a gate or some government exams also, this type of problems will be asked. There you will be getting only 1 or 2 marks problem. Only you have to remember the conditions for critical depth, conditions for critical velocity and minimum specific energy. Let us take one more problem. So in this problem, what is been given? A 3 meter wide rectangular channel carries 2.4 meter cube per second discharge at a depth of 0.7 meter. Determine the specific energy at 0.7 meter depth, critical depth, and alternate depth to 0.7 meter. So as we have studied in a specific energy curve, you know the specific energy curve, that we have drawn the specific energy curve like this. So along the y-axis we have drawn the depth of flow, along the x-axis this is the x-axis and this is the y-axis. Along the y-axis we have drawn the depth of flow, and along the x-axis we have plotted the specific energy, and one curve represents the straight line and the other curve is the hyperbolic. Then the resultant of these two will be this pink line, this curve, pink curve. Okay, then at one particular point where the tangent becomes zero, if you draw a tangent at that point, that becomes if you draw a tangent, the slope becomes zero at that point, and corresponding to that point whatever the energy you will be getting, that is called as a minimum specific energy, and corresponding to the minimum specific energy whatever the depth we get, that is called as a critical depth. And the line when you draw it, it represents critical depth line or critical flow line, and whatever the depth above you get, that shows subcritical flow, and for the subcritical flow the Froude number will be less than 1, and below a critical the Froude number will be greater than 1, and at a critical the Froude number will be 1. And where the slope is 0, at that particular point the energy will be minimum on that curve. Leaving that point, wherever you take the points, here, here, or here, or here, wherever you take the points on the curve, for the given discharge you will be getting two depths. Means the discharge can be passed, this discharge q, which is a constant, can be passed in two different depths. Those depths are called as alternate depths. This we have discussed in specific energy curve and all. So leaving this point, wherever you take, the discharge can be passed in two different depths. Those depths are called as alternate depths or sequent depths. So in this problem what is being asked, so one depth is knowing, what is the another depth? One depth is knowing, what is the another depth where we can pass the same discharge, the question here asked. So write the given data here. 2.4 meter cube is per second is given, y is given, then b is given. Then this is the rectangle channel section. Then the specific energy calculate at 0.7 meter depth. So let us take, this is this channel section or the longitudinal section of channel. The water is flowing. Let us take section 1 and take section 2. Let us take at section 1 the depth of flow is y1, and at section 2 the depth of flow is y2. And at these 2 points, let us take, this is a q1, this is a q2, but q1 equal to q2 here. The same discharge is passing here as well as here, but one depth we are knowing, what is the another depth, the question here asked. So calculate the energy at 0.7 meter depth. So substitute the values of y1 here. Let us take y1 as a 0.7 meter, then y1 v1 square by 2g, but we know q1 equal to a1 into v1. Then here you take the calculate the v1 and substitute back, you will be getting energy at 0.7 meter, that is 0.767 meter is the energy in terms of head you will be getting. Then calculate the critical depth. Critical depth, we know the formula cubic root of q square by g. Then calculate small q. What small q, what it represents? The small q will be the discharge per unit width. Discharge per unit width, that is 2.4 by 3. Then you will be getting 0.8 meter square per second. Then the yc can be easily calculated. Once we know the small q, substitute back here, you will be getting the critical depth. Then the last is, so that is what is the alternate depth to 0.7 meter we need to calculate. So here, how to calculate the alternate depth to 0.7 meter? Then again, as I told, the channel section, this one, take at two sections 1 and 2. At 1 we know the energy and at 2 2 also the same energy. So if the discharge is same, the energy will be same. If the discharge is same, the energy will be remain same. So whatever the discharge passing here, the same should pass here, but in another depth. Okay, so what is that another depth? So again you write the energy at 2, that is E2 equal to V2 Y2 plus V2 square by 2G. Then from this formula we can get Q equal to A into V, that is V equal to Q by A. From this you just substitute here, then substitute all the values of that one, then you will be getting one equation. Just simplify this one, you simplify, go on simplifying it, you will be getting one cubic equation. That equation you are getting in this format: ax cube plus bx square plus cx plus d. Okay, this one in this format you are getting. When you simplify this one, when I substitute v equal to q by a, when you substitute all this one, you will be getting in this format. Okay, that is y2 cube minus 0.767 y2 square plus 0.0326 is equal to 0. Solve this equation. You can solve this equation in calculator. So in calculator you can solve this one. So here I'll show you this one. In this one, that equation, just feed this equation, go to mode, then here equation, go to mode. Okay, you can see this one. Okay, press 1. Then here it is asking unknowns, so don't press anything here. Just in the replay button, right word, press right word. Then when you press right word, you will be getting, it will be asking degree 2 or 3. So in our equation is third degree, just press 3. Then it is asking what is the value of a. A is nothing but coefficient of y cube, coefficient of y cube, that is 1. Then it is b is the coefficient of y2 square minus 0.767. Then it is asking value of c. Here c we don't have, that is cx, that is in this format, ax cube plus bx square plus cx plus d. A is what? Coefficient of x cube, b is coefficient of x square, c is coefficient of x, and d. So in our case we don't have any c value here, then just you feed it as 0 equal to, what is the d value? 0.0326, then equal to. So what you are getting? One depth 0.7, already we are having that 0.7 depth, so we get one depth as a 0.7. And what is another depth? Here it is showing minus, leave this, take one more. So one more depth is 0.25, one more depth is 0.25. I hope you understood this one. Okay, so we can solve this equation easily in calculator. In other time, this fx 991 I am using here, so you can try in another calculation, so you will be getting the same answer. So the discharge q, whatever given here, q that can be passed in two alternate depth, that is y1 is 0.7 meter and another depth y2 is 0.25 meter. And this depth you can compare with critical depth yc. Already we have calculated critical depth, that is 0.403. Critical depth we calculated 0.403. So one depth is lesser than yc, that is this depth produces supercritical flow, and one depth is above critical, that produces subcritical flow. I hope you understood this one. So one depth, that is y1 is less than yc, then yc is less than y2, like this. Okay, so you'll be getting two alternate depths. One depth you can cross verify, already we are having this depth, but we got another depth as 0.25 meter. Okay, so this is so simple problem. Take one more type of a problem. In this problem, the specific energy for 6 meter wide channel is to be 5 kg meter per kg if the rate of flow of water through a channel is 24 meter cube per second. Determine alternate depths of the channel. In this problem also they asked alternate depths, both depths they asked, The energy is given. For that energy, the discharge passing is 24 meter cube per second. So what are those two depths where we can pass the same discharge? Here write the given data. Width of the channel is given b, the rectangle channel section is given, specific energy E is given, discharge through the channel is given 24 meter cube per second. Then to find alternate depths, let us take y1 and y2 be the two alternate depths, and these two depths can be calculated. Then calculate first specific energy E. Write the equation for specific energy E, that is y plus v square by 2g. This formula we are having with us. Then substitute the value of energy here. Then y we don't know, keep as it is y. Then v square by 2g, v can be written, this is the formula we are having with us, q equal to a into v. Then from this get the value of v here in terms of y. Substitute back in this equation, simplify it, 4 by y here. Then you will be getting in terms of y, again you will be getting a cubic equation like this. You will be getting this equation, substitute here, then you will be getting the cubic equation. Okay, just substitute here, you will be getting the cubic equation. Again solve this equation in calculator, you can easily solve this one. Again I'll feed this equation, again go to press mode, go to equation, then press right arrow mark on a reply button. Then it is asking degree 2 or 3, that's 3. Then I'll feed this equation is in the form of ax cube plus bx square plus cx plus d, quadratic equation. Then the coefficient of y cube will be 1, coefficient of y square will be minus 5. Then coefficient of c, that is cx, c is not here, 0. Then d will be 0.815. Write it. So you'll be getting one depth as 4.96 and another depth, it is minus, it is coming, just press, you'll be getting three values, x1 x2 x3, it is cubic equation. Another depth will be 0.4219, that is 0.422, that is 0.42, this is 0.42. I hope you understood this one. You can easily solve this one. So again, this type of problems will be around 8 to 10 marks problems. Just simple problems. Okay. So let us take one more example. This is also a university question paper example only. A rectangular channel of bed width 4 meter is discharging water at the rate of 10 meter cube per second. Determine the following. So what is given here? So what is needs to be find? Critical depth, minimum specific energy, what will be the type of flow in the depth of 0.6 meter and 2 meter. This is the problem asked here. First you write the given datas. What are the datas given? The channel section given here as a rectangular channel section. The datas given here is width of the channel is given, discharge is given. To find critical depth, minimum specific energy, then after calculating critical depth, you have to compare this, compare the given depths with critical depth. Then you can decide whether the flow is a subcritical flow or supercritical flow. Then that is the type of flow. First calculate the critical depth, that is yc is cubic root of q square by g. Then the small q is what? Discharge per unit width, that is 10 by 4. Then you will be getting 2.5. Calculate the critical depth. Then once we get the critical depth, this is the channel section and this represents the critical depth. Then with respect to critical depth, just to compare the given depths, so here the critical depth is 0.860, then the one depth is given 0.6, which is below critical, then it is calling as a supercritical flow, and one more is about critical, that is 2 meter, it is called as a subcritical flow. Then minimum specific energy here, 3 by 2 into yc, you will get the minimum specific energy. Then the type of flows. So how to write the type of flow here? Since the critical depth of yc is 0.86 meter obtained, then the type of flow in depth 0.6 meter. So depth yc is how much? 0.86 meter. Then we can write yc is, y1 is less than yc and yc is less than y2. You can take 0.6 meter as a y1 and that is 2 meter as a y2. Y2 is more than yc and y1 is less than yc. So we can say when you compare this 0.6 meter with critical depth, it is less than critical, hence the flow is supercritical, high velocity. And another is 2 meter is greater than in yc, that is 0.86 meter, flow is subcritical. So this is the answer. I hope you understood this one. Okay, thank you.